We're going to give you a very brief introduction to what's called the fundamental theorem of algebra. And it's super cool. In my thought, it's the coolest part of algebra. I guess that's why they call it the fundamental theorem. The number of solutions to an equation is the same as the largest degree of the equation. The number of solutions to an equation is the same as the largest degree of the equation. Can somebody tell me what is the power of the x right here? What is the exponent? It's just 1. So therefore, there are how many solutions? 1. You don't have to flip it over, but just all this. What is the largest exponent here? So how many solutions are there? 2. What is the largest degree here? So there are 3 solutions. Largest degree, so there are 5 solutions. So sometimes you wonder, how do we know how many solutions we're going to get? You can always look at the degree, and that tells you for sure. Today we're going to focus on first degree and second degree. You ready? We'll go back to something that you remember quite well from algebra, and that is solving equations. Let's work together and try to do this quickly and efficiently. How do I solve A? Subtract 4, 3x is equal to 6, then x is equal to 2. What if I want to check my answer? You can always plug it back in and verify. B is a little bit more difficult. What makes B difficult? What do I have to do with the 2? Do I distribute positive 2 or negative 2? Negative 2. So 3x minus a 2x minus 10 is equal to 10. What terms can I combine? Gives me x minus 10 is equal to 10. X is 20. What makes C more difficult? X is in the numerator. You have fractions, huh? Anybody hate fractions? Okay, I hate fractions too. So let's get rid of them. Actually, let's do something. No, let's get rid of them. Okay. What is the common denominator? 15, right? So watch. I'm going to multiply everything by 15. Every term up here, I wrote multiplied by 15. Now, you don't have to write this out every time. But what is 15 divided by 5? Times x. 3 times 15. 15 divided by 3. 5 times x. 15 times 1. See how I got rid of all my fractions? They're gone. You don't like that. Want to see it again? This time I won't write it out. Look at the common denominator. Okay? And again, we're using this principle. 2x equals 8. What's the solution to that? 4. If I multiply both sides by 2, is the solution still 4? So you're allowed to multiply both sides of an equation by the same number, and it will maintain equality. So again, what is the common denominator between 5, 1, and 3? 15. So I'll multiply everything by 15. 15 divided by 5 times x is 3x. 15 times 3, 15 divided by 3 times x is 5x. And 15 times 1, 15. That way, all the fractions are gone. Now I can combine like terms. Would you like your x's on your left or your right? Okay. We'll subtract the 3x. Negative 45 is equal to 2x plus 15. Subtract my 15. Negative 60 is equal to 2x. X is negative 30. How about this? You try D on your own. Try D on your own. I have a negative 1/2. What mistake do you think might people make once they get to this point? They see 10x is equal to negative 5. Instead of writing negative 1/2, they write negative 2. Their brain just says 10 and 5 and 2. You know, they just get used to that. Okay. What if you have a fraction equal to a fraction? You remember what you can do if you have a fraction equal to a fraction? Cross multiply. 13 distributed to the x makes 13x, and 13 times negative 2 is negative 26. 5 times 2x is 10x. 5 times negative 3 is negative 15. And now we solve. Gather my x's on one side. X is 11/3. So we're not going to come up with integers every time. The solutions won't necessarily be negative 6 or positive 15 or 2 or 11 or negative 1. You do sometimes come up with interesting solutions. You might come up with a single solution. So you get x is equal to 11/3. That's a single solution. But suppose you're solving something and you come up with x plus 1 is equal to x plus 2. 1 second while I get that. Here we go. Suppose you get x plus 1 is equal to x plus 2, and you would subtract the x's. You would get 1 is equal to 2, correct? Is that true? That's a sign that you have no solution. Suppose you get something like 1 plus x plus 1 is equal to x plus 2. When you combine like terms, say x plus 2 is equal to x plus 2. You subtract your x's, you get 2 is equal to 2. Is that true? Then all numbers work. Extraneous solution we'll talk about later when we actually go through and do problem F. So that's a summary of single solutions, okay, where you have an exponent of 1. The second thing we want to do today, we're going to do 3 problems on the backside, is the zero product rule. If A times B is equal to 0, then something is true. If A times B is equal to 0, then something is true. Either this or this is true. What can you say? Either A is equal to 0 or B is equal to 0. Everybody agree with that statement? Has to be true, right? And that makes the zero product property very useful in mathematics. Notice that it is product. Product means you write it as, product is short for, starts with an M, multiplication. Thank you. So right now it's written as addition. Let's write it as multiplication. Can you factor something out here? What can you factor? An x and a 3. So we're going to take a 3x, we're going to put it up front. We take the 3x out. What is left here? 2x plus, what's left here? 1. Everybody pay careful attention. This is my A. This is my B. These two things multiply together. You told me either A is equal to 0 or B is equal to 0. What degree is this equation? What's the largest degree? So how many solutions will I have? 2. Let's find them. How do you solve this? By 3. What is 0 over 3? 0. How do you solve this? Subtract the 1. 2x is equal to negative 1. Divide by 2. X is negative 1/2. You have found your 2 solutions. If on the test you don't list both solutions, it's not fully correct. I'll give you 2 out of 3 points. But if you want the 3rd point, you're going to have to find both solutions. And you know ahead of time that there's going to be 2. Okay? Let's see what you guys remember about this. 9x squared minus 1 is equal to 0. Do you remember how this factors? Difference of 2 squares. What do you multiply to get 9x squared? 3x times 3x. What do you multiply to get negative 1? Positive 1 and negative 1. So let's solve. 3x plus 1 is equal to 0, and 3x minus 1 is equal to 0. 3x equals negative 1, so x is negative 1/3. 3x equals 1, divided by 3, x is positive 1/3. How many solutions did I come up with? Because the degree is 2. The last one is set equal to 12. If I want to use the zero product property, it must be set equal to 0. Don't start factoring it right now. Don't take out an x and say, well, it's negative x plus 8 is equal to 12, so I guess x has to be equal to 12, and if I subtract that, then x is negative 4. No, you just made up voodoo mathematics, and you ruined it. Don't do that, okay? It's called the zero product property, folks. It's called zero product property because it only works for 0. There is no 12 product property. So let's make it equal to 0. I'm going to put the x squared over here. I'll subtract the 8x over here. 0 can be on the left-hand side instead of the right-hand side. That's fine. Does x squared minus 8x plus 12 factor? To what? Minus 6 to minus 2. So I take those two pieces, x minus 6 equals 0 and x minus 2 equals 0. What is the solution? X is 6 and x is 2. Two solutions, second degree. There you go. Good work. We have a few days to get through equation solving. We have quadratic formula, we have squares, we have higher degree polynomials, we have radical functions. So it's going to take us a couple days to get through it, okay? So your assignment for today is it's a book assignment. So you've got 11 problems there, and you've got 5 problems there. So there's total 16 problems. We need the equation we need practice for the equation solving. I want you guys to understand that there's going to come the day where you have to be able to solve this type of equation. You know, we got to be able to solve it with trigonometric functions in the midst of it. It's a little bit different, right? So we need practice for the equation solving. If I can get you to do the stuff early on, you'll be able to do the stuff later. Trust me. So, all right.